Good morning, everybody. Welcome back. Today we're going to talk a little bit about circumference and arc length. So today's Monday, October 19th, and hopefully you finished up the 9 weeks the way you wanted to, but we're going to talk more about that in class as well. So, all right, well, let's take a look. First thing, think about it. So this whole section of circumference and arc length, in the past, students have really struggled to understand, like, what's the difference between the two, when I'm solving for which one, like how to really set it up. So I thought I'd throw this in here at the beginning just to try to help us distinguish between the two pieces. So it says this figure might represent you and a friend running around a circular track. Okay, so I didn't actually draw the figure yet, but this is what it would look like. Looks like that, and then like that. Okay, so we're acting like it's a circular track. All right, you're on the inside lane, so you're on this lane, and your friend is on the outside lane, okay? If you both complete the same fraction of the track, say a quarter of a lap, does that mean that you both run the same distance? Okay, so if you're running around the inside and your friend is running around the outside, would you be running the same distance? Remember that what we talked about in the last couple units is that we have this central angle, right? And let's say the central angle is well, actually, let's just make it what they talked about. So if it's a quarter of the way, it would be right here, right? And a quarter of a circle is 90 degrees. So according to a central angle, that tells us that both this is 90 degrees and this is 90 degrees, right? They both have the same central angle measure. So that means they're the same distance, right? Well, no. Remember, if you've ever run on a track, you know that the inside lane is a lot shorter, it's a lot faster than the outside lane. So that's where this comes into play with the circumference and arc length, okay, is being able to figure out, okay, it might be 90-degree measure, but what's the actual length of this little distance that they're going to run? All right, so let's look at some notations here. First of all, if you see something like this that says AB with a line over top of it, you know that this is segment AB, okay, and that it's typically either a chord or a secant line, which in this case, if we look at the picture that goes with it, it's actually a chord, right, because it just goes to here. There's no lines that extend past it. Remember, there's no arrows. All right. How about if it says M of AB, like lowercase m AB? Well, that means the measure of arc AB, and this is in degrees. So this is similar to what we were saying up above. This is where we'd say, oh, the measure of AB is this many degrees, right? Okay, and then what we have that's new in this section is this one here, and this is arc AB, so very similar to the other one, right? But there's no M. Okay, and this is talking about the length. The length, so could be in centimeters, inches, feet, yards, okay? Just to give you some perspective. All right, some things to know. Circumference of a circle. If you want to know the exact circumference of a circle, remember circumference of a circle is the length around the outside of a circle. Okay, you could also say it's the perimeter of the circle. All right, the exact circumference, and you probably should have memorized this before, is C equals 2 pi r, where r is the radius. Okay, so there's the formula for that. Circumference equals 2 pi r, which in this example to our right, the radius is 6, so our circumference would be 2 times pi times 6, which is 12 pi. Okay, so that's the exact answer because pi is still in there. We're not rounding. Approximate is the rounded version. So the circumference of a circle is, of this one to the right, is 2 times 3.14, because that's what we use for pi, times the radius, which is 2 times 3.14 times 6, which gives you 37.68. Okay, and that would be centimeters. Okay, so that's the total circumference of that circle. All right, so now let's take a look at arc. There are two ways to describe an arc. Okay, you have what's called the arc measure and the arc length. So arc measure is usually written as like MAB, whereas this is just AB. Okay. Arc measure is an angle measure that creates an arc. So again, this is in degrees. So this would be saying this little piece here. Okay. Whereas arc length is the distance covered by an arc. Okay, it's not the whole arc around, it's just these little individual pieces, right? Okay, so when you go to find the arc length, there's a ratio that we can set up, okay? And it's kind of like what we talked about before. It's part to whole. All right? And we're going to set it up to say if we know the arc measure over the entire circle, we know that that is equal to the arc length over the entire circle's circumference. Okay? So we would set up that proportion to work our way through. But basically, it's if it gives you the angle measure of the little angle, then you put that in here. If it gives you the length of the arc on the outside, you put it in here, right? So you just fill in the information for what it gives you. So that we're going to use this ratio a lot, so you need to know it. This might be a thing where you put it down on a note card and memorize it. Okay. Example number 1, find the length of DE, arc DE. So the measure of DE, remember, is the same as the central angle, so this one's pretty easy, it's 45 degrees. But then the length of DE, right, the arc length, we have to say, okay, well, what's the measure? It's 45. How many degrees are in a full circle? 360. Okay. What's the, what are we looking for? We're looking for the arc length, which is on top. And then 2 times pi times the radius is on the bottom, which is 6. Okay, so we're going to work our way through. In this case, it doesn't say approximate or exact, so we're just going to round it. So let's say we have cross multiply. Okay, so we have 360x equals 45 times 12 pi, which, if we put in our calculator, times 12, and pi's down there. Oops, I put 2 pi. Gives you 1696.5. We usually round to the nearest tenth. Okay. Actually, instead of doing that, let's just use, so we're consistent, 3.14. Okay, so we're going to round a little bit. There we go. So that's going to give us 1695.6. Okay, divide by 360. So that number, nope, that ain't going to work. 1695.6 divided by 360 is 4.71. So the length is 4.71. Okay? And that would be centimeters. Okay. So again, that's this part here. Okay, so find the length of the bolted arcs. All right, so you can see this one is 270 degrees on the bolted side, which is the outside. That's what it's talking about. So set up our proportion, 270 over 360 equals the arc length over 2 times pi times the radius, which is 11. So this is going to be 360x equals, when you cross multiply, put it in the calculator, and you would get 18,651.6 divided by 360. X is about 51.81 inches. Okay. What's up, Coach? Good. And then I'll come down. I'm making a video. Then the last one here, we got 90 over 360, because again, it's talking about this one. X over 2 times pi times the radius, which is 15, which is 360x. 30 times 90 times 3.14 is about 8,478. Again, we cross multiplied. So divide by 360, divide by 360. X is 23.55 miles. Okay. All right. So your homework. Go online, complete the 8.3 Canvas practice quiz. You have unlimited attempts to get 100%. Let me know if you have any questions. Remember to write down this proportion at the top of your paper or off to the side so you can use it for that Canvas quiz. All right, guys. Good luck.